Welcome to this video, where we'll explore one of the most common pain points when working with Podman in Kubernetes: getting Rootless Podman to work seamlessly both locally and in a k8s environment. If you're involved in containerization, especially using Podman as your container engine, you've likely encountered issues where your Rootless Podman setup works flawlessly on your local machine, but hits unexpected roadblocks when deployed to a Kubernetes cluster. In this video, we'll dive into the reasons behind this discrepancy and explore how to overcome these challenges. By the end of this discussion, you should have a clear understanding of why Rootless Podman behaves differently in local versus k8s environments, and most importantly, how to ensure it works consistently across both setups. To tackle this issue, let's first understand what Rootless Podman is. Rootless mode allows users to run containers without needing root privileges on the host system. This is achieved by leveraging user namespaces and other kernel features that enable unprivileged users to create their own isolated environments for running containers. When working locally with Podman, this setup often works as expected because the necessary permissions and environment configurations are easily managed. However, things get more complicated when moving your application to a Kubernetes k8s environment. Kubernetes introduces additional layers of complexity, such as pods, services, and network policies that don't directly translate from local environments. A key aspect here is how Kubernetes handles privileges and access control within the cluster, which differs significantly from a standalone machine setup. One major point of friction comes from the way Podman's rootless mode interacts with the Kubernetes nodes environment. In k8s, even though you might have configured your containers to run as non-root users, the underlying infrastructure might enforce different security contexts or lack specific capabilities required by Podman for rootless operation. This mismatch can lead to permissions issues or inability to access necessary resources. To resolve these discrepancies, consider using Kubernetes features that allow more granular control over pod and container configurations. For instance, you can define custom security contexts within your pod specifications to align the privileges of your containers with what's required for rootless Podman operation. Additionally, ensuring that the base image used by your containers has the necessary tools and configurations for rootless mode can also mitigate compatibility issues. Rootless Podman allows running containers without root privileges on the host. Local environments and k8s setups have different permission models which affect Rootless Podman's functionality. Kubernetes features like custom security contexts and pod specs can help align container privileges with rootless mode requirements. Ensuring your base image is compatible with rootless operation is crucial. In getting Rootless Podman to work consistently both locally and in a Kubernetes environment requires understanding the differences in how these environments handle user permissions and resource access. By recognizing where these discrepancies lie and leveraging Kubernetes configuration capabilities, you can ensure that your Rootless Podman setup functions as expected across different deployment contexts. If you have any questions or insights regarding this topic, please don't hesitate to share them with us in the comments below. Your feedback is invaluable in helping others who might be facing similar challenges. Also, if this video has been helpful, consider liking it and subscribing for more content on managing and optimizing your containerized application. Thanks for watching. Wow.